The chain rule, part 2. Welcome back. In part 2, we're going to see some examples that we have to combine product rule with the chain rule, quotient rule with the chain rule, and use chain rule multiple times. So let's start. Example, find h prime of x if h of x equal x to the 5th power times tangent of x squared. So you can see h of x is made out of a product of two functions. First function f is x to the 5th power, and my second function is tangent, but it's not tangent x, it's a tangent of x squared. So my second function g is a composition of two functions as inner function x squared and outer function tangent. So to take the derivative of h, we need to use product rule on this function f times g, and while you take the derivative of g, because there is an inner function and an outer function, you need to use chain rule here. So let's take the derivative of h. So h prime of x equal, we just said we need to use product rule. Product rule was f prime times g plus f times g prime. So then since f is x to the 5th, f prime is 5x to the power 4 times g. We just write g. So you copy tangent x squared plus back to f. F is just x to the 5th times g prime. Remember, now this is a composition of two functions, so we need to use chain rule on it. So take the derivative of outer function first. Derivative of tangent is secant square. So you will have a secant square of input, and now you multiply by derivative of inner function, and since the inner function is x squared, derivative of that would be 2x. So now all I have to do is clean this up. So this is equal to 5x to the 4th tangent x squared plus x to the 5th times 2x is 2x to the 6th power secant x squared. And to write the answer in factored form, I would look at the common factor, and common factor is x to the 4th power. So you factor out x to the 4th power, then I will have 5 tangent x squared plus 2x squared secant x squared. This is our h prime of x. Okay, let's do another problem. Find y prime if y equal quantity 3x squared plus 5 over 4x squared. So now you got something big to the power 2. Is that right? So this is again the composition of two functions. This time your inner function is rational function and outer function is power function. So we need to use chain rule right away. When you take the derivative of inner function, that's when you have to use the quotient rule, since your inner function is a quotient. Make sense? So let's find the derivative. My y prime is equal to, let's take the derivative of outer function. Since I got something to the power 2, when you take the derivative of that, it will be 2 times something to the power 1, and 1 I don't have to write it, and at this time I don't do anything to my inner function, so I just gotta copy it down, times by derivative of inner function. And derivative of inner function, since my inside function is a quotient, I got to use the quotient rule. And remember what the quotient rule was? Low d high minus high d low over square below. So here's a high and here's a low. So let's go ahead and do low for x times d high. Derivative of high is 6x minus high is 3x squared plus 5. D low is 4 over square below. When I square the 4x, I get 16x squared. So now that's your y prime, and I just have to clean this up. So I'm going to cancel this 2 with this 4, and then I will have 3x squared plus 5 factor on the top. I still have a 2x in the bottom. And then if I clean inside there, I have 6x times 4x is 24x squared. And I have to distribute the negative. I also need to distribute the 4. So I'm gonna do that at the same time. So negative 3x squared times 4 gives me negative 12x squared. Negative distributed to 5, that's a negative 5 times 4. That's gonna be negative 20 over 16x squared is what I have. But that simplifies more inside of a bracket, as my numerator is 24x squared minus 12x squared. That is 12x squared. So let's clean that up one more time. So I have 3x squared plus 5 factor on the top, 2x in the bottom, and I have a 12x squared minus 20 now over 16x squared. But I see that 12 and 20 still have a common factor 4. So let's pull that out because we need to reduce as much as we can. Then this is going to be 3x squared plus 5 over 2x times, pull out 4. You have then 3x squared minus 5 over 16x squared. 4 goes there once, 4 goes there 4. So my final answer is equal to 3x squared plus 5 times 3x squared minus 5 over 2x times 4x squared is gonna be 8x to the third, and this is what my y prime is. Now let's practice some problems that we have to use chain rule more than once. Look at first example, g of x equal cosine cube of 4x. This, if I rewrite it, it is cosine 4x to the third power. That's exactly what this function is. So if you look at closely, my outer function is a power function, and my inner function is cosine of 4x. But because cosine of 4x is again composition function of cosine x and 4x, this is really f of, since they already used the letter g, h of k of x, where kx is 4x and hx is a cosine function and f is a power function. So to take the derivative of 3 composite functions, we need to use the chain rule twice. So then, how do you do that? To do this, first, you take the derivative of most outside function, and then at the point, you don't do anything to what's inside. Now you need to multiply by derivative of middle inside the function, and you don't do anything to the most inside the function. And then lastly, you gotta multiply by the derivative of most inner function. That's how you would take the derivative of composition of 3 functions. So let's go ahead and take the derivative of that. So then g prime of x is equal to, remember, the most outside function is a power function. So I'm gonna take the derivative of that, which is 3 times, I'm gonna write everything exactly the same. But because I'm just taking care of the most outside function, I'm gonna lose 1 power and it's gonna become power 2. But now I gotta multiply by, now you take the derivative of middle function. And middle inside the function is cosine of something. When you take the derivative of that, then you get negative sine of something. And then lastly, I need to take the derivative of the most inside the function, and derivative of 4x is 4. So that is everything. Now we simplify this. Then our g prime of x is equal to, so you multiply 3, and there's a negative 1 and a 4. So that's gonna be negative 12. And you have a sine of 4x. And cosine of 4x, it is a square, so it is cosine square of 4x, and that is your answer for g prime of x. Okay, let's look at another one. F of x equal tangent of square root of sine of 2x. So let's rewrite this. I have tangent of sine of 2x and the whole sine function to the 1/2 power. That's what I have right now. So my most outside function is tangent because the power 1/2 doesn't apply to tangent. It is only for the sine of 2x. So what is really sitting the most outside is tangent. And then inside of tangent, I have something to the power. And then inside of power, I have sine function. And inside of sine function, I have 2x. So again, I have a tangent function, and then I have a power function, and then I have sine function, and then I have linear function. So this is composition of 4 functions. So you need to use chain rule 3 times. So let's go ahead and take the derivative of that one at a time. My f prime of x then is equal to derivative of tangent is, yes, it's a secant square, and then I'm just gonna write exactly same thing what I have because I'm not supposed to do anything to the input. Now I want to take the derivative of the power function. And my power function is something to the 1/2 power. So if I take the derivative of that, then it is 1/2 times something to the negative 1/2 power, and my something is what I shaded with the highlight. So that's a sine of 2x. And then I gotta times that by derivative of sine function. And derivative of sine is cosine function. So it's gonna be cosine of that. And now I need to take the derivative of 2x, which is 2. So now I just gotta simplify this. So I'm gonna cancel this 2 with this 1/2. And let's see. What I have on the numerator is secant square root of sine 2x times cosine of 2x. And this part here, since it is negative exponent, you can send it to the denominator and it will become positive 1/2 power, but because positive 1/2 power is again square root, you can put it inside of a radical sine of 2x. And that is your f prime of x. Next examples involve radicals or radicals in the denominator. That will give us negative exponents or fractional exponents. And when we simplify these, it could give us a lot of complication. So let's review how to factor negative exponent or fractional exponent. So let's just say I have a 6x to the negative second power times y plus 4/5 x squared y to the negative third power. How would I factor this and simplify and make a single fraction answer? To factor this, since there are negative exponents, we will have a probably denominator anyway, and we do have a denominator already with the 4/5. So it is better to put them together in a single algebraic expression. So first term, just multiply top and bottom by quantity 1. Since the common denominator will be 5, so you can multiply the first expression by 5 on the numerator and 5 in the denominator. So quantity 1. This expression then is 30x to the negative second power y plus 4x squared y to the negative third power over 5. So now factor the numerator. 30 and 4 have a common factor 2. And between x to the negative second power and x to the second power, we learned that we always pull out the smallest power of the two. And that will be negative second power. So you're going to pull out x to the negative second power. between y and y to the negative third power. Of course, we choose y to the negative third power, and then we take care of what should go inside of parentheses. So 2 times what is 30? That will be 15. And x to the negative second power, it's already out. Y to the negative third power times y to the what should give me y power when I add exponent, y to the power 4, because we add exponent when we multiply these two, and negative third power plus power 4 give me positive 1 power of y, plus 2 times 2 gives me 4, x to the negative second times x to the positive power 4 give me, when I add it to exponent, it will give me x to the positive second power, and y to the whole negative third power is out, so I don't have any factor of y, over 5. And because these two are negative exponents, you can send to the denominator to turn into a positive exponent. So my final answer, when it's simplified, it will be equal to 2 times 15 y to the power 4 plus 2x to the power 4 over 5 x to the second, y to the third. Let's do the next problem. So any radicals or any powers in the denominator, we want to change it to rational exponent or negative exponent to avoid the quotient. 8x to the 3/2 power minus 18 over square root of x. Let's rewrite this. This is equal to 8x to the 3/2 power minus 18 x to the negative 1/2 power, right? So this is equal to, between 8 and 18, common factor is 2. X to the 3/2 power and negative 1/2 power, you choose lower power, which is x to the negative 1/2 power. Then factor inside should be 2 times 4 equal 8. X to the negative 1/2 plus x to the what power? Negative 1/2 plus what half give me 3/2? That will be 4 halves. And 4 halves is just power 2. Minus 2 times 9 is 18. And whole x to the negative 1/2 is out. So then, since x to the negative 1/2 power is negative exponent, you're gonna send to the denominator, so we can use positive exponent. And positive 1/2 power is again square root of x, so you can put it back to radical. And also, this is a square minus b square, so it factors more. And since it says factor each expression, you should factor completely. So your answer then will be equal to 2 times, this is 2x squared, quantity 2x squared minus 3 squared. So it factors more as 2x plus 3, 2x minus 3 over square root of x will be your final answer. So now, let's take the derivative of product of functions involving radicals, either on the numerator or in the denominator. My h of x equal x squared times the square root of 1 minus x squared. So we need to rewrite it using rational exponent. And this is equal to x squared times 1 minus x squared to the 1/2 power. Yes, so you need to use product rule. You can call this one f times, you can call the second one g, but what do you know about g? Well, your g is not just x to the 1/2 power, it is a function to the 1/2 power. So when you take the derivative of g, you need to use chain rule because it's a composition of two functions. So let's take the derivative of h. and we're going to use product rule, of course, and that will be f prime times g plus f times g prime. And what is f prime? That is 2x times g. You just write g. And what's g? G is 1 minus x squared to the 1/2 power plus f is x squared, and g prime, we need to use chain rule. I got a power function. It's something to the 1/2 power. So take the derivative of outer function. That will be 1/2 times something to the negative 1/2 power. And I do not touch what was inside. And now I need to multiply by derivative of inner function. And inner function is 1 minus x squared. So when you take the derivative of that, you get negative 2x. Okay, so now we want to simplify this, and we just learned how to simplify this. Okay, first of all, let's cancel this 2 with this 2, and be very careful with the sign. There's a minus sign here, so in between these two terms, we will locate the minus in between when we write the answer down. Now, you notice they both have a common factor x. I have a factor x here, and I have a factor x here. So x is a common factor. Also, I have a 1 minus x squared to the 1/2 power and 1 minus x squared to the negative 1/2 power. Their power is different, but your base is the same. That means it is a common factor. So you just choose the lower power of the two. So when I factor this out, I'm going to have x and then 1 minus x squared to the between 1/2 power and negative 1/2 power. We choose the lower of the two powers. So that will be negative 1/2 and open bracket. And because now from this one, when I multiply with these two, I have to get this fourth term back. X is already out, so I still need to put 2 inside. And with this times 1 minus x squared to the negative 1/2 power plus what half a power is gonna give me positive 1/2 power back, that will be 2 over 2, because negative 1/2 plus 2 over 2 give me positive 1/2, but 2 over 2 is 1, and 1 we don't have to write it, so it will be just that. Now for the second part, remember this minus. This factor is going to be multiplied by the negative 2x, so it's going to be negative in between now. And that 2 and this 2 got canceled. And then this factor right here is already out. So, and then I had a 1x here, and I have another x here. Only 2's got canceled. So there's another x there. So what I really have left on the second term is x squared. But when we simplify this on the side, this bracket, it will be 2 minus 2x squared minus x squared, which is equal to 2 minus 3x squared. So that's what I'm going to put in the bracket when I write the answer down. So this is a numerator, and this will go to the denominator, and this is still numerator factor. So my answer will be x times 2 minus 3x squared. And when this factor goes to the denominator, you can turn into the square root. So that's gonna be square root of 1 minus x squared. And that is very simplified answer of your h prime of x. Let's keep going. Y equal x over cube root of x squared plus 4. We should rewrite this, right? And your denominator is quantity x squared plus 4 to the 1/3 power. We want to bring that to the numerator so that we would have a product x times this is quantity, x squared plus 4 to the, since you brought from the denominator, it's going to become negative exponent 1/3 power. Okay, so again, we need to use product rule. You have function f times g, but g again is something to the power. It's not x to the, it is a function to the negative 1/3 power. So when you take the derivative of g, you have to use chain rule again. And of course, take the derivative of y, we should use product rule since it is f times g. So y prime is going to be again f prime times g plus f times g prime. So f prime is just 1, correct? And g, just copy my g. My g is x squared plus 4 to the negative 1/3 power plus f. F is x and g prime. I gotta use chain rule. Outer function is something to the negative 1/3 power. So when you take the derivative of that, I get negative 1/3 times something to the lose 1 power. What's negative 1/3 power minus 1? That will be negative 4/3 power. And what was inside? I don't touch. And then I multiply by derivative of inner function. And derivative of inner function is 2x. Okay, so I just got to simplify this. Now here, I do have 3 in the denominator. So to make a single fraction answer, let's have a common denominator. And common denominator will be, of course, 3. So let's multiply top and bottom of the first term by 3. So I would have 3 times x squared plus 4 to the negative 1/3 power. I have minus here, and I had x times 2x, so this is 2x squared, and I have x squared plus 4 to the negative 4/3 power over, they both have a denominator 3, so I can use it as a common denominator. So then, from the numerator, you can see that they both have a common factor, x squared plus 4 factor. And I'm supposed to choose lower power of the two powers. And my powers are negative 1/3 and negative 4/3. Which one is lower? Negative 4/3. So you are going to take the x squared plus 4 to the negative 4/3 power out. Then you get 3 inside. And x squared plus 4 to the what power added to negative 4/3 power will give you back negative 1/3 power above. That will be positive 3 over 3. But positive 3 over 3 is 1. So this is it. And then minus 2x squared. And x squared plus 4 to the negative 4/3 power is all out. So over 3. So you just have to clean the bracket inside. And my bracket is 3x squared minus 2x squared is x squared plus 3 times 4 is 12. And then I had a 3 in the bottom. And this is negative exponent, so you need to send to the denominator. So when you send to the denominator, it turns into a positive exponent for third. So that will be our simplified derivative in a single fraction. Find all points on the graph of f of x equal cube root of quantity x squared minus 1 square, where the tangent line is horizontal or vertical. So what does that mean? Are they asking me to find the tangent line? No. It says find all points. So I just need to give ordered pair points. What kind of ordered pair? Where tangent line is horizontal. What does it mean that tangent line is horizontal? Guys, what is the slope of horizontal line? That will be slope 0. So I need to find where you have a tangent line of this function would have a slope 0. So I need to find out when this f prime of x, since derivative is a slope function, is 0 for the horizontal. And for the vertical, a vertical line, we call the slope is undefined. So I want to know when this function f prime of x does not exist. And that will be undefined, right? Does not exist, it's undefined, so you will not have a slope there, which will be vertical. So bottom line is, again, I need to find f prime of x. So let's do that. And to find f prime of x, we want to rewrite this function. And this is quantity x squared minus 1 to the 2/3 power. And you can see that I have a composition of two functions. My outer function is a power function. My inner function is x squared minus 1. So my f prime of x then is equal to, take the derivative of outer function first, which is 2/3 x squared minus 1 to the, when you lose one power from 2/3 power, it will be negative 1/3 power. And then I need to multiply by derivative of inner function, which is 2x. So when you simplify this, my numerator is this times this. That's your numerator, which is 4x. And 3 was the denominator, and you need to move this factor here. Since it has a negative exponent, you need to bring it down to the denominator. And because 1/3 the power was a cube root, you can put it back to the radical notation, and it will be cube root of x squared minus 1. And you just found your derivative function. So now look at it. This is your f prime of x. And when is this f prime of x equal 0? This is a rational expression. Any rational expression is 0 when numerator is 0. So this numerator is 0 when x is 0. So this will be equal to function value 0 when x is equal 0. And rational expression is undefined if denominator is 0. And you can see this expression denominator will be 0 if x squared was equal to 1. And x squared is 1, that means x is plus minus 1. So this f prime of x does not exist when x is equal plus minus 1. But now I still need to find all points, order the pair, such that f has a horizontal tangent line or f has a vertical tangent line. So you can now write the answer down and say f has a horizontal tangent at where? I know x is 0, and what is the y value? I need to find a point on this original function. So to find the y coordinate, you need to plug this value into original function. So what's f of 0? Let me calculate out here. F of 0 is cube root of 0 squared minus 1 squared, which is equal to cube root of 0 squared is 0, subtract 1 is negative 1, negative 1 squared is positive 1. So I got cube root of 1, which is 1. So that will be 1 here. And f has a vertical tangent line at 1 comma, because we have vertical tangent at x equal plus minus 1. And I see that when you square 1 or negative 1, I'm gonna get the same y value. So since 1 squared is 1, negative 1 squared is 1, this you can use plus minus 1, comma, I'm gonna get a same y value. And f of 1 is cube root of 1 square minus 1 square. Do you see, even if I do negative 1 square, it's gonna turn into a positive 1. 1 square is a positive 1. So I will get the same value here. So cube root of 1 minus 1 is 0. So I get 0. So this will be 0. So you found all points on the graph of f where the tangent line is horizontal or vertical. Find the equation of the line tangent to fx equal 3 cosine x plus cosine 1/2 x at the point pi comma negative 3. Here, it does say to find the equation of a line. So I'm going to find the equation of a line, and since it didn't say what form to give, I'm going to just leave the point slope form. And here is my point pi comma negative 3. So all I need is the slope at x equal pi. So to find the slope m at x equal pi, I need f prime of x. So f prime of x is equal to derivative of 3 cosine x will be negative 3 sine x plus cosine 1/2 x. This is not cosine x. So this is a composition of two functions. Outside the function is cosine. Inner function is 1/2 x. So you need to use chain rule here. So to take the derivative of that, cosine of 1/2 x derivative is negative. So let's change this to negative sine of input times, now you multiply by derivative of inner function, which is just 1/2. This is it, pretty simple. So my f prime of x is equal to negative 3 sine x minus 1/2 sine of 1/2 x. So my slope m at x equal pi is f prime of pi. So plug pi for every x you see. Negative 3 times sine pi minus 1/2 sine of 1/2 times pi, which is pi over 2. So then that's equal to negative 3. Sine of pi is 0, right? So that will be 0 minus 1/2 times sine of pi over 2 is 1, which is 0, subtract half, which is negative 1/2. So I found the slope. Slope is negative 1/2. And now you found the slope m with the point pi comma negative 3. You are ready to write equation of a tangent line, and the point slope form of a line is y minus y1 equal m parentheses x minus x1. So let's write the answer. Our answer is y minus minus 3 equal m parentheses x minus pi. And here is our equation of line tangent to this function at pi comma negative 3. Higher order derivatives involving the chain rule. So now, given f function, let's find the second derivative. So let's say my f of x equals sine of x cubed. So this, I cannot rewrite it. Notice this is just sine of, your input is x cubed function. So outer function is a sine function, and your inner function is x cubed function, okay? Don't get confused with the sine cube of x. This is a sine of x cubed. Sine cube of x is a sine x times a sine x times a sine x. Get it? Okay, let's find f prime of x. So f prime of x, I need to take the derivative of outside the function first. So that will be cosine of input. Now you multiply by derivative of inner function, which is 3x squared. So your answer is 3x squared cosine of x to the third power. Now, to take the second derivative, you gotta look at this as product, right? This is your g times cosine of x cubed now become h. So to find the derivative of this, which is the second derivative of f, you need to use product rule. And while you are using product rule, you need to use chain rule for the h function, since h function is cosine of x cubed. Got the idea? So let's find f double prime of x, which is equal to, you need to do what? G prime times h plus g times h prime. And what's g prime? Since g is 3x squared, g prime is 6x times h, I just copy. So cosine of x cubed plus g, I copy, 3x squared times h prime. Remember, to take the derivative of a cosine x cubed, I need to use chain rule. Now take the derivative of outside, which is cosine function first. Derivative of cosine is negative sine of input. And now I need to multiply by derivative of inner function, which is 3x squared. There you go. So now I just need to simplify this and I have a second derivative. So this is equal to 6x cosine x cubed. It's gonna be minus 3x squared times 3x squared is 9x to the 4th power sine x cubed. And we have been write the answer in factored form. So let's factor this answer. Common factor of these two terms is 3x. So factor out 3x. Open bracket, then I will have 2 cosine of x to the 3rd power minus 3x to the 3rd power sine of x to the 3rd power. And that will be my f double prime of x. Okay, this is the last problem of this section. G of x equal cotangent of 3x. Find g double prime of x. So let's do it again. It's not cotangent x, it's a cotangent of 3x. So this is a composition of two functions. My outside function is cotangent and my inside function is 3x. Okay, so my g prime of x is equal to derivative of outside function, which is cotangent x, is, what's the derivative of cotangent? That's a negative cosecant square. Cosecant square of input times, I gotta use chain rule. Derivative of inner function is just 3. Oh, that was not bad. So this is just negative 3 cosecant square 3x. But remember, this is negative 3 times cosecant 3x squared is what this is. So for you to find the g double prime, you have a power function as the most outside function, and then you have inner function as a cosecant, and then you have a most inside the function as a 3x. So you need to use chain rule twice here. Okay, so let's go ahead and do that. So my second derivative of g, which is g double prime of x, is take the derivative of most outside the function, which is a power function. I will have negative 6 times bracket to the lose 1 power. I get only power 1. 1, I don't have to write it. And my inner function is cosecant of 3x times, now I need to take the derivative of middle inside the function, which is a cosecant function. And derivative of cosecant function is negative of cosecant of input, cotangent of input. And I still need to multiply by the derivative of most inside the function, which is 3x, and derivative of 3x is 3. So now my final answer is, let's see, I have a negative 6, there's another negative 1 factor, and there's a positive 3. When you multiply those 3, I get positive 18. And you have cosecant of 3x and cosecant of 3x, that is cosecant square of 3x. And you have one factor of cotangent of 3x, and that is your g double prime of x. Good job, guys. Like I said, the chain rule is one of the most important rule for taking derivatives. You must master it because it is all over the place. So please study hard, and I'll see you guys again in section 2.5.